Hi, super chemists out there in King William County. This is Tracy Folks going over your in-class notes just in case you needed to hear it again. These were our notes on metric conversions, and we were just talking about the metric system. We talked about some base units, okay? We said that if we're talking about mass, it's always in grams, liter is volume, meter is length, and time is second. So those are our base units. That's where we start from. And then the next slide went over some really crazy poo numbers that we're going to be using all year. So remember, these are things you're going to have to just memorize. And if making some flashcards makes your life easier, it is well worth the effort. This is like gum on your shoe. We're doing it all year. It is not going anywhere. So make sure you're putting a little time in just memorizing the numbers that go with it. Some of them you probably already know from middle school, you know, kilo, thousand, centi, 100. But those nanos and picos, those are new for us. So it's going to take you a while to grow accustomed to using them. And don't worry, we will kind of beat a dead horse with that. Now, I know in middle school sometimes they teach you to do metric conversions by moving the decimal. And remember, that does not work for us in the land of super chemists because the numbers we use are so big and so small that moving the decimal is just not going to work. So we use something called dimensional analysis, okay? And I know it sounds goofy at first, but our problems are going to get super big, and if we're all doing them the same way and have the same logic and format, it's going to make your life so much easier as we go along. Okie dokie, artichokes. So I'm starting with the first example. The first example says Brittany wants to know her height in meters. She knows that her height is 1.86 kilometers. She is a tall girl, okay? So always take what's given and put it over 1. Because when you put something over 1, you haven't really changed it at all. Anything put over 1 is just itself. So put it over 1. Haven't changed it at all. Put a little exy poo-poo. Draw a little line there. Whatever unit I'm trying to get rid of, in this case it's kilometers, I want those to go away. That unit goes on the bottom of the next step. The unit that I want, what I'm looking for, that's going to go on the top or in the numerator. So if you look at this problem, it says that I'm looking for meters, so that goes up here. All right, what happens there? I got to have some numbers. Who's bigger, a meter or a kilometer? The bigger unit in that conversion gets the number 1. So I know because I'm a super chemist that kilometers are bigger than meters, so that gets a 1. Here comes metric prefixes where you have to have these memorized. There are 1,000 meters in a kilometer. Okie dokie, artichokes. Now I just plug and chug in the calculator. It's all easy from this point. Now why does this magic work? This magic works because anytime in math you have something on the top and something on the bottom, they cancel out. So kilometers is on the top, it's on the bottom, they cancel out. I'm left in meters. So I multiply across the top, 1.86 times 1,000, and that gives me that number. I multiply across the bottom. This one's kind of easy. 1 times 1 is 1. Top divided by bottom. Then you got to give me these units that are left over. And for my super chemist, you have to circle your answer because it just makes my life easier. It makes that answer pop. Okay? So that's what I want to see every time you do a dimensional analysis problem. The next example, looking at the next example from your notes, and you know you have these from class. They're also posted on Schoology. Okay? During a lab, Becca poured 4.2 times 10 to the 2 milliliters of hydrochloric acid into a beaker. How many liters is this? I don't care that Becca's in a lab. I don't care that she's pouring hydrochloric acid. That's in there to confuse you. If I were you, I would circle the number you're given and circle the unit you want and ignore everything else. Okay? So in this problem, I have 4.2 times 10 to the 2 milliliters. This exponent thing, this does not give me the heebie-jeebies because I am a super chemist and I know my scientific notation because we went over that on day 1 and I'm good to go with that. So take what's given, put it over 1, exy poo-poo. Now, I want to get rid of these milliliters. Anything I want to get rid of goes in the bottom of the next step. So these milliliters come down here. When I look at this problem, I am asked for liters. Liters is what I want. So that goes up top or in the numerator. All right. Beating a dead horse with this. Gotta know these prefix numbers. Okay. Who's bigger, a liter or a milliliter? A liter's bigger. So liter gets 1. How many milli anything? Milli is like millennium. How many years in a millennium? 1,000. So every time you see milli, it's 1,000. Milli is always 1,000, just like there's always 1,000 years in that millennium. All right, so I'm good to go. I'm where I want to be. I'm going to start multiplying across the top. Oh, and I'm going to cancel some stuff out. Milliliters is on the top. Milliliters is on the bottom. Poof, it goes away. Okay? 4.2 times 10 to the 2 times 1 is 420. Okay? Or your calculator might just say 4.2 times 10 to the 2. Either way, you're good to go. All right? 1 times 1,000, just multiplying across the bottom, is 1,000. Now, I plug and chug this in my calculator. Top divided by bottom. 420 divided by 1,000 is 0.420. My units that I'm left over with are liters. I circle my answer because I am a super chemist. Shazammy poo poo. I am done. All right, let's get this party started. Let's keep rolling. The next example. Let's see, where are we? The next example. Owen needs to, I'm on this one. Here you go, right here if you need a little peeksy poo. Owen needs to obtain 5.3 times 10 to the negative 1 grams of sodium chloride for his experiment. How many nanograms does he need? All right, again, I don't care about Owen. I don't care about his experiment. I care about the number that's given and what I want. So I take what's given and I put it over 1. 5.3 times 10 to the negative 1 grams over 1. And you know, you can always get partial credit for me. You can always take what's given and put it over 1. That's showing me that you at least learned something, okay? Never leave anything blank for me. There's always something you can show me. All right, so take what's given, put it over 1. I want to get rid of these grams here. Anytime I want to get rid of a unit, it goes on the bottom of the next conversion. So grams is on the bottom. I look at my problem, I want nanograms. So nanograms is going to go on the top, okay? Who's bigger, a nanogram or a gram? A gram just sounds bigger. Nano sounds tiny. So gram's bigger, so it gets a 1. Now remember our cheer from class. When I say nano, you say 9, nano, 9, nano, 9, okay? So nano will always, did I say always, get 1 times 10 to the 9, okay? Nano's always going to get that in your conversions for the rest of the year, for the rest of your chemistry career. That's what nano's going to get. Alrighty, I can start crossing some stuff out. Grams is on the top, grams is on the bottom, poof, it's gone. So now I'm just going to multiply the top across. So 5.3 times 10 to the negative 1 times 1 times 10 to the 9, which sounds a little crazy, poo. It's really not. One times 1, this one's kind of easy, it's just 1. So my answer is 5.3 times 10 to the 8 nanograms with a circle, okay? Shazammy poo-poo. There we go. All right, the next example. All right, the next example kicks it up a notch, all right? This is at the point where I said we're doing little 2-step problems here. And if you've noticed from this point, I've always either started with a base unit, so that means something without a prefix, or gone to a base unit. Now I'm going to do something that's going to require 3 steps. I'm going to start with something that has a prefix, and I'm going to a unit that has a prefix. Okay? And we're going to do a couple of examples. Actually, I can just leave that there for you. Alrighty. I'm on this one. A chemist needs 5.6 times 10 to the 14 picograms of iron. How many kilograms is this? Okay, here we go. Take what's given and put it over 1. Everybody at this point can do that. 5.6 times 10 to the 14 picograms. Exy poo-poo, draw myself a line. Don't want to be in picograms. How do I get rid of it? Put picograms on the bottom. Now, I want kilograms. Can I go to kilograms? Heck no. And here's why. Because this has a prefix, I always have to go back to the base unit. Well, shucky darn and slap the chickens. I forgot my base units. No worries, Hakuna Matata. I can cheat because Mrs. Falks taught me how to cheat, right? All right, when you cover that first letter, that tells you what the base unit is. So I'm just going to go to G, or grams. Now, who's bigger, a gram or a picogram? Gram's bigger, it sounds bigger, it gets a 1. Every single time you write pico, you will use the same number. When I say pico, you say 12. Pico, 12, pico, 12, okay? So, every time I have a conversion with pico, 1 times 10 to the 12. That's what's going to go there, okay? Every single time. Now, got rid of picograms. I'm in grams. I'm not happy. This problem asked me for kilograms. So I've got to do another exy poo-poo. Get rid of grams. Put grams on the bottom. Okay? And now I can go to kilograms. What's bigger, a kilogram or a gram? A kilogram's bigger. It just sounds bigger. So it gets a 1. How many grams in a kilo? 1,000. Now, you will plug and chug across the top, plug and chug across the bottom, and get your answer. So, this times this times this is that. Multiply across the bottom. Okay. Top divided by bottom. Shazammy poo-poo. Okay? Give me a number, give me a unit, give me a circle. All right, let's do another one. We're going to do this one. Here we go. A student runs 0.26 megameters. How many centimeters did he run? Or she run? Here we go. Do I care that they're running? Do I care that they're outside and it's nice? Nope. As soon as I see that problem, I just take the number that's given and I put it over 1. And I just for doing this long, I write the X, I draw the line, and I know that I'm going to get rid of this megameters because I don't want it. So I immediately just put it on the bottom there. Now in this problem, I was asked for centimeters. Can you go from megameters to centimeters? Heck no, you have to go back to the base. So you cover up that mega. What's my base? Meters. Who's bigger, a meter or a megameter? Megameter, it just sounds bigger. So that gets a 1. How many meters in a megameter? Mega million. That's how I remember it. So it's always a million. And I cheat and write 1 million that way because I think it's easier. And then I'm going to go, don't want to be in meters. So I'm going to get rid of it. And what I really, really want are centimeters. So that's going to go on the top. Who's bigger, a centimeter or a meter? Centimeters bigger. Excuse me. Oh, shucky darn and slap the chickens. Meter is bigger. Centi will always get 100. Just like there are 100 years in a century, centi will always get 100. You're going to multiply across the top, multiply across the bottom, and you get the magic number of that. I hope this helps you review your notes. I'm looking forward to seeing you in class again. Remember, I'm just an email away if you have any questions.